All right. So these first problems, okay, again, we're 1.6, so I have that at the beginning. The angle lies at the center of a circle and subtends an arc of the circle. Okay, that's like just, you can ignore that part. Find the missing angle measure, circle radius, or arc length. Okay, I don't think I put it in here yesterday. Oh, I did. S equals r theta. Okay, so that's the formula we're using. Remember, theta has to be in radians. So, let's see, number 2. We have theta is 175 degrees. Radius is what we're trying to find. And arc length, which is S, is 10. So how do I convert that theta into radians?
Divide it by 180 and multiply it by pi.
Yep. So 175 and then divide by 180, multiply by pi. And obviously know that 5 goes evenly into both. I don't know if anything else does. Nope. So let's see. 175 divided by 5. 35 pi over 36, not pi on the bottom. So 35 pi over 36 is my new theta. So now I just use S equals r theta. So I need r, so S divided by theta. 10 divided by 35 pi over 36. Divide by a fraction. Okay, multiply by the reciprocal, so 10 times 36 divided by 35 pi. And do y'all have what that's equal to? What? Did you divide by pi? And you got 32? Well, it should be I got 3.27 when I do it. Well, 10 times 36, and then divided by 35, and then divided by pi. Huh? And the other thing to potentially make this less confusing is up here. Obviously, when we're doing conversions from degrees to radians, we leave it like this with the pi in it. But if to make your life easier, you wanted to go ahead and do this, and then just put a label on it that's in radians now, that would be fine too. And then that might help, because then you're just doing 10 divided by 3.05. to get 3.25, or if you do it this way and you leave it, I got 3.25. If you do it with this number, I get 3.27, so it's close. All right, 4, theta is what we don't know. Radius is 6, and arc length is 3 pi over 2. So S equals r theta. Need theta by itself, so I'm going to do S divided by r. So 3 pi over 2, all divided by 6, okay, which is the same thing as multiplying by 1/6. So 3 pi over 2 times 1 over 6. And I would say at this point, just simplify it to get that. Because it's an angle, so we don't want to divide it all the way through. All right. So the next ones say in exercise 9 and 10, find all the trig values of theta with the given conditions. So number 10, tangent of theta is equal to -1. Sine of theta is less than 0. Okay, so that means the y values have to be negative, so I know when I go to draw it, it's going to be in the bottom. Okay. So if tangent is negative, that has to occur where one value is positive and one value is negative, right? One x and one y. Since this right here, the sine of theta being less than 0, has to be negative, that means that my x value needs to be positive. So I'm down here. Oops. And remember, I always connect with the x-axis, okay, when I draw it. So we know that based on this, y has to be -1. Tangent is y over x. So if that's -1, this has to be 1. And then this is a special triangle. It's a 1, 1, √2 triangle. So we now have it labeled. And then we just need to go through and do each of the values. Reading them off. So sine is going to be -√2 over 2, or yeah, well, hold on, let me rephrase. -1 over √2. Can't have the root on the bottom, so it's going to be -√2 over 2. Cosine is going to be 1 over √2, which will rationalize to √2 over 2. Tangent was given to us. We can just copy that one down. And the only reason I really care about you writing these ones, okay, the first one that's not the rationalized one, is because it will help you when you go to write cosecant and secant. Because I just need to take them and just flip them over. So this one's just going to be -√2. Secant is just going to be root 2, and cotangent is just the inverse of that, which in this case is still going to be -1. This all ring a bell? They do have a lot of graphing problems in this section that I don't really have you guys doing. If there's something that needs to be graphed, you can use your calculator for it, or if you want to check it, that would be the way to go about doing that. Alright, so then I'm going to jump down a pretty big space, and we're going to go to 28. Okay, all that stuff in the middle we're not really doing. So these say to give the measure of the angle in radians and degrees, give the exact answers whenever possible. So the arc sine of negative root 2 over 2 where does that fall on the unit circle? So where do the sine values occur for inverse? Do you remember?
Is that what our sign is?
Yeah, the inverse arc.
Directly across from the circle.
What do you mean? Does it occur? Because some of the functions occur up here, and some occur over here.
It would be in the fourth one.
Yep. And remember, it's negative pi over 2 to pi over 2 is what sine is dealing with. So where is it? Negative root 2 over 2. It would be down at minus pi over 4. Okay, on the unit circle, it would look like it's at 7 pi over 4. But remember, we're negative pi over 2 to pi over 2 for these values. So it's going to be minus pi over 4 or negative 45 degrees. If you have one like 30, okay, the arc cosine or inverse cosine of 0.7, okay, this is one you would just do on your calculator. You just need to make sure you have your calculator in radian or degree mode. Okay, since it asks for both, you just have to change the modes between them. All right, now I'm in degree mode, so arc cosine of 0.7, I just did the wrong thing, is 45.6 degrees. And if I switch modes over to radians and do the same thing, at 0.795. Okay, if it doesn't have the pi in it, make sure you write radians with it. Let's see. Solve the equation in the specified, oh wait, never mind, I'm not going to do those ones. Use the given information to find the values of the 6 trig functions at the angle theta. Give the exact answers. So 38 theta is equal to inverse tangent of negative 5/12. Alright, so we need to set up to draw a picture. So for tangent, or inverse tangent to be negative, okay, it's got to be down in that bottom right quadrant, okay? It also falls on the right-hand side like sine does. So that means we're going to be drawn down here like this. And we're opposite over adjacent, so 5 and 12. Or wait a second. Did I write that wrong? Now I need to look because I thought I had that right, but in my notes I have it written as something else. So let me check before we go too far. I had it right. I have it wrong in my paper. That's why I was confused. Okay, 5 and 12. Okay, this 5 has to be negative. Do y'all know what special triangle this is? It's a Pythagorean triple. Potentially. Do you know what the other value is? 13? Yeah. Okay, that's one of those special ones, a 5, 12, 13 triangle. All right, so then we just would write all of the, obviously, well, let me back up. Obviously, you could do this Pythagorean theorem as well. But then we would just come over and we would write each of the 6 values. So sine is opposite over hypotenuse, so negative 5/13. Cosine, adjacent over hypotenuse, 12/13. Tangent was given to us, negative 5/12. And then I just need to take and flip them for the other ones. So cosecant, negative 13/5. Secant, 13/12. And cotangent, negative 12/5. All right, and then one last problem here. Number 42. So this one says to evaluate the expression. So I think we saw some of these last year. It'll be tangent of the inverse sine of 9/13. Okay, we did them more right off the unit circle. So we found the inverse sine value, okay, the angle that it gave us. And then we took, like, we would have taken like the tangent of that value. So in this case, 9/13 is not something we know right off of the unit circle. So you're just going to use your calculator in radian mode. So you have to do, well, you probably can actually type the whole thing in all at once. Yeah, we'll let you. So do the tangent of the inverse sine of 9/13 and then close the parentheses off. And it may not actually matter what mode you're in. Oh, it doesn't matter which mode you're in. Ignore that. These aren't the ones that it matters. And so if you do that, enter that exactly on your calculator, you get 0.959. All right, so problems I would recommend with this. I would look at 5 through 8 only because that's the even or odd. Okay, I would just look at them and see if you remember which ones are which, and then look back in your notes and see if you got them right. Since that, I'm telling you 100% will be on the quiz. 9, and then jump to 27, 37, and 41 would be my recommendations there.